Hey guys, welcome back to the channel. In today's video, we are going to build a note-taking app like this one. This app will have functionalities like adding, editing, and removing notes. Additionally, we will implement a sorting functionality that allows us to order notes by their last modification date and enable searching for specific notes within the list. This tutorial will be an excellent opportunity for us to explore fundamental concepts in Flutter, such as how to properly handle navigation between screens, how to retrieve user selection from a dialog box, dynamically render a list view, and some advanced use of the text field. If you want to follow along, you can go to the GitHub link in the description below to download or clone the starter project. Switch to the starter branch, then click on this drop down and download the zip file. Once that's done, you can open the starter project in your preferred editor. For me, I will be using VS Code. While the app is launching, let's quickly come here in the lib folder to go over the files and folders that I have already prepared to save us some time. In the constant folder, we have a list of background colors that I will use for the background of the cards. For the model, we have a simple node class with some basic properties: an ID, a title, a content, and the last modified time. We also created a constructor for that class. And down here, we have a list of sample nodes that we will use within our app. For the screens, we will have two: a home screen and an edit screen. And as usual, we have the main.dat file with the main method, which is the starting point of our app. It runs the main app class, which is the stateless widget. The build method of this class returns a material app that has a scaffold with a text widget at its center. Now we are ready to start coding our app. And the first thing we will do is to come here and create a stateful widget for the home screen. Now we can go back and replace this scaffold by the home screen that we just created. Back here inside the scaffold, we will first add a background color. We will set it to a dark shade of gray. Then for the body, we will use a column to vertically lay out the widget inside the home screen. To create this text and icon button at the top, we'll come here inside the column and add a row. And inside this row, we will add a text widget and style it with a font size 30 and a white color. Then add the icon button. We will set its own pressed callback later. For now, let's just add the icon and set its color to white. The widgets are not positioned correctly. To fix that, we'll come here and wrap the column with a padding. We will use the from left top right bottom constructor of the agency class. And to create some space between them, we will set the main axis alignment of the row to space between. Now to finalize this icon button, we will wrap the icon with a container. We will set its width and height to 40 and use its decoration property, which takes a box decoration, to give it a dark gray color with 80% opacity and set its border radius to border radius circular 10. The icon button is too small, and to fix that, you might tend to come here and add a padding to the container. But as you can see, that doesn't work. The best way to understand this is to come here in the command palette and activate the Flutter toggle debug painting. If we take a closer look, we can see that the icon button already has a padding. That's why the container is so small. So to fix that, we can come here and remove this padding by setting the padding property of the icon button to edge and set 0. Now if we deactivate the debug painting, we can see that the icon button has the white size. Now let's move to create this search text field that we will use to filter the nodes in the list below. For that, we'll come here under the row, still inside the column, and add a text field. And to make this text field look like this one, we will use its decoration property, which takes an input decoration. We'll start by adding a hint text, then use the hint type property to give it a gray color. We'll use the prefix icon property to add an icon before the input text area. For the background, we will set the fill color to a dark shade of gray, and to see it, we need to set the field property to true. Now, to make the corners rounded, we'll use the focused border property, which takes an outline input border. We'll set its border radius to circular 30 and the border side to a transparent color. The text fill is too high. Let's fix that using the content padding of the input decoration and set it to edge and set symmetric vertical 12. Then let's add some space between the row and the text field using the size box widget. The text inside the text field should be white. For that, we'll use the style property of the text field to set its font size and its color to white. Now, one thing to note is that if we restart the app, the rounded corners are gone. This is because earlier we only set the focus border, which defined the border appearance of the text field when it has focus. To keep the same appearance when it doesn't have focus, we need to also set the enabled border property to the same outline input border. Now the rounded corners remain even when we restart the app. Now let's continue to build this list of cards that we'll use to display our notes. For that, we'll come here under the text field to add an expanded widget. We need an expanded widget because we are going to add a list view inside a column. This will avoid the vertical viewport was given unbounded height error. Now inside this list view, we will use a list style to display the different information related to a note. We will set the title property of the list style to a rich text that we'll use to display the note title followed by the note content. We use a rich text widget because it allows us to display multiple blocks of text, where each block of text is a text span that can have its own style. But keep in mind that we could achieve the same thing using a column with two text widgets. Now, let's wrap the list style with a card so that we can see it better, and then come down here and set the subtitle property to the note last modified time using a text widget. Then use the text style to give it a font size of 10, font style italic, and a gray color. Those two are too close to one another, so let's add some space between them by adding a padding around the text widget. Now let's use the trailing icon of the list style to add an icon button that we will use later to delete a note. To make the corners of the card more rounded, we'll come here and set the shape property of the card to a rounded rectangle border. Then give it a border radius circular 10. Now, before we populate this list view with our list of simple notes, let's come down here and add the floating action button that we will use to add a new note in the list. As a child, we will pass it an icon, then set the background color to a dark shade of gray, and set the elevation to 10. I think we're done creating the main widget for this home screen. Let's continue to populate this list view with our list of simple notes. For that, we'll come here and replace the default list view constructor by the list view builder constructor. This will help us to create a code for each item in the sample list of notes. It has two properties that are required, an item count and an item builder. For the item count, which represents the number of items to show in the list, we will pass it the sample notes.length. The item builder, it's a callback function that gives us an index that we can use to build each item in the list. In our case, it will return this code that we created earlier. Now we just need to refactor the card to reflect the correct values from the simple note list using the index argument from the item builder. We'll do the same for the content text. Now, to avoid having cards of different sizes, we can come here in the rich text and set the max lines property to 3. That means 1 line for the title and 2 lines for the content. And for the case where the content will go over 2 lines, we'll use the overflow property of the rich text and set it to overflow ellipsis to show the 3 dots at the end. Now let's continue to refactor the last modified date. And to make it display the date and time in this format, we will need to use the date format class from the Intel library. But first, we need to import the Intel library in our pubspec.yaml. And since we have added a new package, let's stop and restart the app. Now we can come here and use the date format class to format our date and times. Don't forget to import the Intel package. Let's finish that by adding the edited text in the front. The text in the list style are too close to the edges of the card. So to fix that, we will come here and wrap the list style with a padding. Now to set the background color of the cards, we would normally come here and set the color property of the card to a specific color. But since we would like to have a different background color for each card, we will use our list of predefined background colors to randomly assign a background color to each card. So for that, we'll come here and create a function. We'll call it getRandomColor. For that function, we'll start by creating a new instance random of the random class. Don't forget to import the math library. Then we will use it to generate a random index between 0 and the length of the list of background colors. Once we have that index, we can use it to select a random color from our list and return it. So since the index is random, the return color will also be random. That means we will have different colors each time the screen is refreshed. Let's finish this list view by reducing the padding at the top. We'll set it to edge and set only top 30. And also increasing the margin between the cards. So we'll set the margin property of the card to edge and set only bottom 20. Now we're done with this list view. Let's continue to add the search functionality where the user can find a note based on its title and content. For that, we'll come here and add another function. We'll call it onSearchTextChanged. It will take a search text as parameter. Inside this function, we'll call the where method on the sample note list. This will check for each note whether the content or the title contains the search text. So at the end, the where method will return a list of notes that match that condition. And we will put it in a new list called filtered notes. Let's create it and initialize it to an empty list. Now we can come down here and use the onChange callback of the text field to call the onSearchTextChanged and pass in the value entered by the user. Or we can simply set the onChange callback to the onSearchTextChange function without the parentheses. Now, if we try to enter a value in the text field, nothing happens. This is because in our function, we put the result in the new list called filtered notes. That means we need to come in the list view and replace the list of sample notes by the filtered note list. Now the list view is empty. This is expected since the filtered node was initialized to an empty list. To fix that, we'll override the initState method and set the filtered node list to the sample notes. Now if we restart the app, we have our notes back. And finally, to update the list while the user is typing, we need to come back to the function and use the setState method. Now let's continue to implement this button that we'll use to sort the items in the list based on the last modified time. So for that, we'll come here and create a state variable, sorted, and initialize it to false. Then we'll come here and create the function that will actually do the sorting. Let's call it sort notes by modified time. It will take a list of notes as parameter, sort it, then return it. So if sorted, the function will sort the list of notes in ascending order based on their modified time. This is achieved by calling the sort method on the list and passing a comparator function that compares the modified time of two notes A and B. Else, that means sorted is false, the function will sort the list of notes in descending order based on their modified time. This is done simply by swapping the position of A and B in the comparator function, which will reverse the sorting order. After sorting the list, we need to toggle the value of the sorted variable. That means the next time we'll call sort node by modified time, the sorting order will be reversed. Now we can come down here in the onPress callback of this icon button, set state, filtered nodes receive sort node by modified time, and pass in the filtered node. Now when we click on this button, it will change the order of the item in the list based on their last modified time. Let's continue to implement the code for this delete button. Again, we'll come here, add a function, delete node. It will take an index as parameter, the index of the item in the list, then set state, and inside of the set state, we will call filtered nodes and use the remove at function and pass in the index. This will remove the item at the specified index in the list. Now we can go down in the onPress callback of this trailing icon button and call delete node and pass in the index of the current item. If we come here and click this trash icon, it will delete this node in the list. Now, as we all know, it's always a good practice to ask the user for a confirmation before deleting an item in the list. For that, we'll come here and call the show dialog function. It takes two name parameters, a context and a builder. The builder parameter is a callback function that in this case will return an alert dialog widget. We will set its background to a dark gray color, the icon to display in the title of the dialog to an information icon with a gray color. For the title, we will use a text widget with a white color. To lay out the two buttons at the bottom, we'll use a row, and inside this row, we will add an elevated button. We will set the onPress to an empty function for now, and for the child, we'll just copy and paste this text widget, set its alignment to text align center, and we place the text here. Now to set the size of the elevated button, we will wrap the text widget with a size box with a width of 60. Let's change the color of the button using the style property of the elevated button style from, and set the background color to a green color. Now, in the onPress callback of the elevated button, we'll call the navigator pop to close the dialog box. We'll also return true, which means the user agrees to remove the note from the list. Let's also create the other button by copying and pasting here. We'll change the text widget to no, the color to red, and the return value when the dialog box is closed to false. The buttons are too close to one another, so let's add some space between them using the main axis alignment of the row. Now that our dialog box is complete, we need to retrieve the selection of the user. For that, we'll come here and create a final variable result to receive the selection of the user. Then we'll come down here. If result, that means the user has selected yes, we will delete the node at the current index. Now to better organize our code, let's extract this dialog box in a method. We'll call it confirmation dialog, and it will take a build context as parameter. To avoid this error when the user dismisses the dialog without selecting yes or no, we need to come here and first check if result is different from null, then check if it is true. Now, one last thing before we finish with this home screen is to make sure that we also delete the node from the sample node list. So for that, we'll come here in the delete node function. First, retrieve the deleted node based on its index. Then call the remove method on the sample node list and pass in the deleted node. Now all the functionalities for the home screen are implemented. Let's continue to allow the user to add new nodes or edit existing nodes. For that, we'll come here in this edit file and create a stateful widget. We'll call it edit screen. For now, it will simply return an empty scaffold. Let's go back to the home screen, then go to the floating action button. In the onPress callback, we'll add the code to navigate to the edit screen. For that, we'll use the navigator.push method. It takes a context and a material page route. Let's add them. Now we can navigate to the edit screen by tapping on this floating action button. The first thing we will do here is setting the background color. For that, we'll go up in the scaffold, copy the background, and go to the edit page and paste it there. For the body, again, we will use a column. And to keep the same layout as the previous page, let's wrap it in a padding. To make sure that we keep the same padding, let's copy it from the home screen and paste it. Now to add this back button at the top, again, we'll go back to the home screen, copy this block of code, and paste it there. We will implement this onPress callback later. Let's remove the node text widget and change the icon. We now need to add two text fields, one for the title and the other for the node content. And since sometime we might need to scroll down because of the length of the node content, we will put them in a list view. So for that, we'll come here, first add an expanded widget, then the list view. Inside this list view, we'll add a text field, then we will use its decoration property to remove the border by setting the border to input border none. Add a head text, title, then style it using the head style property. We need to also style the text that will be inputted by the user using the style property of the text field. Now we can just duplicate this text field to create the one for the node content. The content text will be smaller. So let's remove the font size properties. Also, let's change the head text. To finish with this edit screen UI, let's add this floating action button at the bottom. For that, we'll come here. Under this padding, inside the scaffold, we'll add the floating action button. We'll set the onPress callback to an empty function for now. We'll implement it later. The child will be an icon save. We'll set the background color to a dark shade of gray. And then the elevation to 10. Now we're done with the UI. Let's implement the code for the back button. For that, we'll go up in this onPress callback and call navigation.pop context. Also, to retrieve the user input from the text field, we'll need to create two text editing controllers. One for the title and the other for the node content. Now we can come down to those two text fields and set their respective controllers' properties. Now we have a way to collect the user input. Let's go down to the onPressed callback of the save button and call navigator.pop to return to the home screen. We will give it the context, and as we saw earlier, we can also set the second parameter to return some data. In this case, we will return a list that will be made of the title controller.text and the content controller.text. Now we can go back to the home screen, especially in the onPress callback of the floating action button where we have the code to navigate to the edit screen. As we can see here, the push method returns a future. That means we can come here and wait for the result that will be returned by the push method from the edit screen. Then we can come down here, check if result is different from null, then call simple node add, and use the constructor of the node class to create a new node. We'll set the ID to sample node.length, the title to result at index 0, the content to result at index 1, and the modified time to the current date time. We need also to reset the filtered nodes to the updated sample node list. Before we can test it, we need to add all this in a set state so that we can see the newly added node in the list view. Now we can add new nodes. We need to also give the user a way to edit existing nodes. The way we will implement that is when the user taps on a specific node, it will open it in the edit screen where he can edit the node title or the node content. And then when the user hits save, it will navigate back to the home screen and update the node that was tapped. So for this, we'll come here in the list style and add the untap property. In here, we'll add the code to navigate to the edit screen. So if we tap on this node, it will bring us to the edit screen. But as you can see, we are missing the node title and the node content that we want to edit. To pass those values to the edit screen, we will come here and create a state variable node, which will receive the values of the node that was tapped. We are adding this question mark because when we want to add a new node, this node property will not be set, so it will be null. Let's add it to the constructor as an optional parameter. Now, to see the title and the content in their respective text fields, we can override the initState method. Then in there, initialize the title controller with the text editing controller constructor and pass in the widget node title as value for the text. And since our node state can be null, we need to add this exclamation mark for the null check. We will also do the same thing for the content controller. Now we can go back to the home screen and set the node property for the edit screen to filtered node index, which represents the node on which the user has tapped. The node content text is cut off, so to fix that, we can go back to the text field and set the max line property to null. Now we have the node title and the node content, but after editing them, we need to update the corresponding item in the list. So for that, we'll come back in the untap property of the list style, and as we saw earlier when we were adding a new node, we will receive the result that will be returned by the push method when the user taps on the save button. Since it's almost the same logic, we can copy this code and paste it there. So if result is different from null, we will set state, and then first we will need to get the index of the current selected node. For this, we will create a variable original index. Now we can replace sample node at original index by a new node that will be created based on the values in the result list. Using the node constructor, the ID will be set to sample node original index .id. Then the title, content, and modified time will stay the same. We'll also do the same thing for the filtered node list that we are using to display the nodes in the list view. Let's test it to see if it is working. As you can see, our changes are reflected in the home screen. So that's it guys, I think we have added the basic functionalities of a node app. In a future video, we will explore different ways that we can persist our nodes with the different storage method available in Flutter. So please subscribe if you haven't done so yet, and if you found some value in this video, please give us a like. And I'll see you in the next one.